Hi fellas, this is Chemaddicts again with the solution. Welcome back to my another video tutorial. Well fellas, now we gonna solve the second part of this question. Okay, so the question was number 4. The question was number 4. uh, let's review the question once again. The first steps of two different reaction mechanisms are shown. Okay, so two different mechanisms were given. Okay, two different mechanisms were given, and here at first we need to we have compared these two things. We have found the similarities between these two mechanisms. Okay, so the first question was, what do both reaction mechanism steps have in common? So before we have discussed about the similarities of these two mechanisms. Okay, so fellas, if you have missed the previous mechanisms, if you have missed the previous solution to this problem, don't worry, I'll put the link at the end of this tutorial. Okay, for the time being, let us move on to the next question. Okay, so now we're gonna solve part B. So in part B, it says, the question says, only one of the first steps above leads to what? Is it A, B, C, or D? Okay, so at first let us read the question. Only one of the first steps above, is it leads to the formation of a racemic mixture? Is it involves initial attack by a nucleophile? Involves initial attack by a nucleophile, involves initial attack by an electrophile, leads to an elimination. So which one it should be? So before going to the answer, at first let us discuss the mechanism of this reaction. Okay, two different mechanisms of two different reactions over here. Okay, so here as we can see that it is they both have different structures. Okay, since they are different compounds. Okay, this one is one compound and this one is another compound, so normally they will have different mechanisms. Okay, so now let us have a look to the mechanisms of these two things. Okay, so now let us compare. Well fellas, here it has one common thing, that is these both are attacked by nucleophile. Here this NC is a nucleophile, here OH is also a nucleophile. Okay, so this is one thing is in common. Another thing is common is that one bond is formed over here and one bond is broken over here. Here one bond is formed over here and another bond is broken over here. So there are two similarities. Okay, so now let us at first draw the structure of these molecules. So if we draw the structure in other way around, it would look like this. Okay, CO, then H3C, then this should be CH2, sorry, the structure would look like this: CH2, then H3C. Okay, so it is since it has carbon oxygen bond in the middle of this thing, so this would be keton. Okay, so here this is the structure of keton. So this is a keton, since there is carbon oxygen bond between these two. So well, let me draw this much more clear. All right, so here we can see that this is a ketone molecule. So here there is one thing that we can see here is the shape around this carbon atom, this particular carbon atom that is already bonded with oxygen has trigonal planar structure. Okay, so this has a trigonal planar structure over here. Now let's have a look to the structure of another molecule. Okay, this molecule. So if we redraw the structure of this molecule, this would look something different. Okay, so let's concentrate to the carbon that is bonded with bromine. This particular carbon is being attacked by nucleophile. So let's concentrate on this carbon, since this carbon is being attacked by nucleophile, and the main reaction happens over here. Okay, so here as we can see that here this carbon atom is initially bonded to 4 different groups. Okay, here we have bromine group on this side, and here we have methyl group on this side, and here we have another methyl group on this side, and here it has also hydrogen group attached to this carbon on this del plus carbon atom. Okay, so now let us redraw the structure of this molecule, concentrating on this carbon atom. Okay, on this particular del plus carbon atom. Okay, so if we draw, it will look something like this. So this is the carbon atom del plus that is been attacked by nucleophile. This should be CH3. Okay, here this should be, here we have bromine, here we have hydrogen. Okay, and behind we have CH3. So as we can see that this is a tetrahedral arrangement. Well, let me draw this much more clearer. CH3. Fine. Now we can see that this is a tetrahedral arrangement around this del plus carbon atom that is being attacked by a nucleophile. Okay, so now let us compare these two mechanisms. Here we have hydroxide nucleophile. Okay, the electrons are on the oxygen. Here the electrons are on the oxygen. Okay, that would be donated to this carbon atom, del plus carbon atom. Here the nucleophile is hydroxide, here the nucleophile is cyanide, that is Cn. Okay, Cn minus. Fine. So here as we can see that here the main difference between these two things is this is a trigonal planar shape around this carbon atom, and this is a tetrahedral shape around this carbon atom. Okay, so since this is a tetrahedral shape, extremely sorry, here we have trigonal planar shape. Okay, trigonal planar shape. Since this is a trigonal planar shape, so there are more space around this carbon atom. Okay, around this del plus carbon atom, so this nucleophile can attack either of this side. Okay, so it can attack on above this carbon atom or below, the other way will do. So there are two possible regions where this nucleophile can attack. Okay, that is, one is above like this, all like that. That means there are two possible region. Okay, since if we consider this plane region, trigonal planar region, so here we have space on the above and below carbon atom. So here we can see that there are two-way attacks possible, two possible way attacks. Okay, two-way attacks. So here we can see two-way attacks. So here we can see that two-way attacks. So this reaction forms a racemic mixture, since CO part of the carbonyl molecule is a trigonal planar which can be attacked by NC minus nucleophile from either of the two sides with equal probability. Okay, so here this reaction would form a racemic mixture. Why? That's because CO, this CO part of the carbonyl molecule, this is a carbonyl molecule, is a trigonal planar. The main reason for being racemic mixture, for forming the main reason behind the racemic mixture is that this carbon atom, this particular carbon atom has a trigonal planar. Okay, so this CO group has a trigonal planar shape. So therefore this nucleophile can attack this molecule from either of the two sides with equal probability. So it may attack over here or it may attack from here. So the probability is same on both sides. So two different molecules would form. Okay, so two different optical isomer will form, two different enantiomers will form. Okay, so as a result the optical activity would be cancelled. Okay, so here we have the racemic mixture. Okay, so now here the cyanide ion is attacking above this carbon atom. Now we can also draw the mirror of this molecule, the mirror of this mechanism over here. So if we draw, then this should be look like this. Okay, let's make this shorter, C2H5. So if we write this in short, there are two carbon atoms, so C2, then this is H5, you know. Okay, so now this cyanide ion, since there is plenty of space below this carbon atom, so the cyanide ion can also attack below this carbon atom, del plus carbon atom. Okay, so here, sorry, this should be carbon, not nitrogen. Okay, so this carbon atom would donate this nucleophile, this carbon atom of this nucleophile will donate these electrons to this del plus carbon of this carbonyl compound, so hence forming two different enantiomer. So reaction which forms two different enantiomer is called racemic mixture. Okay, so here we get a racemic mixture, since this reaction forms a racemic mixture, since this CO this group, CO group, is a trigonal planar which can be attacked by NC minus nucleophile, this particular nucleophile, from either of the two sides, either from above or below this carbon atom. There are space above this carbon atom and below this carbon atom with equal probability. Okay, so that is the reason. Now let us have a look on this structure. So here we can see that this structure is tetrahedral arrangement. Okay, so since there are four groups attached to this carbon atom, So there are 4 groups attached to this carbon atom, so this will give its tetrahedral arrangement. Okay, so here just like this, if we compare with this, and if we compare this molecule with this molecule, then we can see that here we have space above and below this carbon atom, but in here we have only space here over this carbon atom, but below we have CH3 group. Okay, so the only space available here is this space, so the nucleophile can attack here. The only possible reason that the nucleophile can attack is here, so there is only one way that nucleophile can attack. Okay, so this reaction doesn't form racemic mixture, since C del plus atom that is attacked by the hydroxide nucleophile has tetrahedral arrangement. As a result, there is only one way for hydroxide to attack. Okay, so this reaction doesn't form doesn't form racemic mixture. This reaction doesn't form racemic mixture, since C del plus atom of this molecule that is attacked by the hydroxide nucleophile, this nucleophile has tetrahedral arrangement. So this molecule has, since this molecule has tetrahedral arrangement, so this hydroxide will attack only in this region. Okay, as a result it won't form racemic mixture. Okay, so that's the reason behind this thing. So here we have find out one thing. Let's move on here. So now we have find out that this reaction mechanism forms a racemic mixture, whereas this mechanism doesn't form racemic mixture. So this doesn't form racemic mixture. Okay, so this doesn't form racemic mixture and this form racemic mixture. So here only one here the question says only one of the first steps above leads to the formation of a racemic mixture. So they have asked us about only one molecule, so here it is the only molecule that forms a racemic mixture, not this one. So that is why this should be the answer A. Now let's move on to B. Why B shouldn't be the answer, why the other options shouldn't be the answer. Let's see here. Involves let's look at B now. Involves initial attack by a nucleophile. So here both of these molecules, if we observe that both of these molecules are being attacked by nucleophiles, so they have asked about only one molecule, but in here both the molecules has been attacked by the nucleophile, so that is why this shouldn't be the answer. Okay, since both of them are being attacked by the nucleophile, but here they have asked about only one. So in order to be this answer, in order to this to be the answer, one of them should be attacked by the nucleophile, but other shouldn't be attacked by the nucleophile. Then this answer would be valid for this condition, but here both of the molecules are being attacked by the nucleophile, so that is why this answer is invalid for this particular condition. They have asked about only one molecule. Okay, I hope that you have get it right. Now let us move on to C. Why C shouldn't be the answer? Let's check out C. Involves initial attack by an electrophile. So since, as we can see here, there is no electrophile is present in both of this mechanism. Since there is no electrophile attack, since this is not an electrophilic attack, in this mechanism, in both of these mechanisms. So there is no electrophile present in either of these mechanism. So that is why this shouldn't be the answer. Okay, now let's move on to D. Since there is no electrophile, this is not an electrophile, this is a nucleophile. So now let's have a look which is nucleophile and which is electrophile. Nucleophile is electron pair donor, rich people are called nucleophile because they have electrons. Okay, and sorry, and an electrophile, let me get this straight. Well, this electrophile means electron pair acceptor. Okay, electron loving species is called electrophile, electron loving species. Okay, so electrophiles are the poor guys who are wanting electrons, and nucleophiles are the rich guys who are willing to donate electrons. That's the difference. Okay, so I hope that you have get it clear. So here this is the nucleophilic attack in this molecule, and this is the nucleophilic attack in this molecule. So since there is no electrophile present in both of these mechanism, so that is why C option C is invalid. Now let us move on to D. So here it says leads to an elimination. So let us know what is meant by elimination. Okay, so elimination simply means, elimination is the reaction where HCl or water are formed as byproducts. Okay, so in elimination reaction, in an elimination reaction where water or HCl are formed as byproducts. Okay, since there is no water or HCl are formed as byproducts in this reaction, in this mechanism, so these shouldn't be the choice. Okay, so here since no HCl or water are formed as byproducts by loss of atoms or groups of atoms, so since no water or HCl are formed as byproducts by loss of atoms or groups of atoms, so this shouldn't be the elimination reaction. Okay, so in here no HCl or water are formed in this particular mechanism. In these two mechanisms we can see that here we can see that there is no HCl or water are formed as byproducts by loss of atoms or groups of atoms. Okay, so that is why this shouldn't be the answer. Okay, okay, so now let's look why this shouldn't be the elimination reaction. So here if we look that this after being attacked by this nucleophile, this nucleophile gets joined with this carbon atom forming O minus over here, but later on we can see that this oxygen then combine with hydrogen. Okay, HCl or HCN, whatever. So later they form bond with this one or this one, forming OH. Okay, so there there is no, as a result, there is no product such as there is no product such as HCl, okay, or water. So there is no possible products such as, there is no possible byproduct such as water or HCl in this reaction, okay. That is why this shouldn't be the elimination reaction for this first reaction mechanism, okay. Now let us move on to this second reaction mechanism. So if we have a look, we can see that after being formed, after forming bond with this nucleophile over here, so this will get kicked out. So this bromide then forms bond with something else, but here there is no byproduct like water or HCl. There is no such thing as HCl or water is formed over here, so this is not an elimination reaction, okay. For this reaction to be elimination reaction, here this hydrogen, this corresponding hydrogen should get kicked out with this bromine in order to be elimination reaction, then they can form HBr, water as byproducts, okay. Here it is also same for this one. Here this hydrogen doesn't kicked out along with this one, so this doesn't make any water as a byproduct, so that is why this shouldn't be the elimination reaction. For elimination reaction, two corresponding atoms should be removed from this molecule, and this would result HCl or water as a byproduct, okay. So that is why this shouldn't be also the answer, okay. So this is not the option, okay. So that is why this is not the answer. So the only correct answer is this. So fellas, this is the answer. Let me review this once again. So here they have asked only one of the first steps involved, one of the first steps involves leads to the formation of racemic mixture. So this if we review here this molecule forms a racemic mixture. Here this doesn't form a racemic mixture since this is a trigonal planar molecule, okay. This part of this molecule is trigonal planar and this molecule is tetrahedral. So this molecule, this carbonene molecule forms racemic mixture since this is a trigonal planar molecule, since this nucleophile can attack either of the sides with equal probability, forming racemic mixture. So this will form racemic mixture, but this does not form racemic mixture. Why? That's because the shape of this molecule is tetrahedral, okay, and the only space for the nucleophile to attack is this one, this space. So the only space is here. So this is the only space that nucleophile can attack, okay. So thus not forming racemic mixture. So fellas, I hope that you have understood the question as well as the solution. So fellas, if you are still in confusion, please let me know in the comment section, okay. So ask question if you have any question regarding this topic, okay. So fellas, let me know how was my solution to this problem. Are we am I able to solve your solution in this video tutorial? Let me know, okay. So if you find this video tutorial helpful, please leave a like. So if not, please leave a dislike. I will prefer any of them, okay. I love like as well as dislike, any one of them will do, okay fellas. So that's it for today. Signing out for now. So fellas, stay cool, stay awesome, and as always, peace with chemistry, and best luck for your exam. Best of luck for your exam, and as always, peace with chemistry.